So, is it possible for us to solve a logarithmic equation if we have two different bases? Some people say yes, some people say no, and some people don't know. Let's have a look. We have log base 2 of x plus log base 4 of x that's equal to 1. We can actually solve it, and the answer is actually quite nice. But you do have to be careful though. The equation cannot be too complicated, otherwise it's not going to be solvable in a nice way. So firstly, notice we cannot combine the logarithm yet because the bases are different. Well, we can actually use the change of base formula first, which says if you have log with a legitimate base b of some input x, this right here is equal to the regular log, which is log base 10, and then you have the x right here over log. As long as the top and bottom log are the same, this will work. And you put the base b right here as the input now, like this. You could also have done natural log of x over natural log of b. So this right here will give us, let's use the common log or log base 10. So log of x over log of 2, and we add this right here is log of x over log of 4, and now it's equal to 1. So far so good. And the good thing about that is this and that are the same now. However, the denominator is not quite the same yet. What can we do next though? Depends on how you want to do it. This right here, log base 4. No, log. This right here, log of 4. 4 is the same as 2 squared. And we can use one of the properties right here as well. Let me just put this down. So note, if we have log of, let's say, something inside raised to the nth power like this, and again, it works for any base, as long as it's legitimate. You can put the power to the front, and this is n times log. You still maintain the same base, and the input stays the same. Yeah. So notice, log of 4. The 4 is the same as 2 to the second power. So we can bring the power to the front and say that is 2 log of 2. So I'm going to just replace that with this. And now as we can see, here we have 2 log of 2, but this is just log of 2. This part match, but let's just multiply the top and bottom by 2 so that this and that will have the same denominator. Very nice, huh? And you can combine them, and then you can get, depends on how you want to approach it. I'm just going to put them together. The denominator is 2 log of 2. Well, the top, here we have 2 log of x plus 1 more log of x. So altogether, we have 3 log of x, and that's equal to 1. And then we can just multiply both sides by the denominator. So we get 3 log of x equals 2 log of 2. And then we can just divide both sides by 3. So let me just do that real quick. And we will get log of x. It's equal to, let's look at this as the coefficient. So we have it like that. Now both sides have log, but here we have 2/3 multiplying with that. Just like the log property earlier, but this time we can actually do it backwards. We are actually going to do it backwards. We'll put this back here to make it exponent first. So it's like this, and we have log of x. That will be log of 2 raised to the 2/3 power. Now, ladies and gentlemen, log is a one-to-one function. That means if both sides have the same log base 10, that means the input has to be the same. Or you can also argue it like this. You can say, you can do exponentiation 10 to this power and 10 to this power and cancel it. Doesn't really matter. But let me actually just do that. I think it's slightly more legitimate. Anyways, cancel. And you will only have this being equal to that. Anyways, x is equal to 2 to the 2/3 power. And depends on how you want to write it. You could also have written this as 2 to the 2/3 power made that into the cube root, and then 2 to the second power, which is just 4 inside of the cube root. Yeah, so of course this right here works too.